Hi guys, welcome back to Ryan Study Corner. I am Ryan and in today's video we are going to be doing the Pendulum Lab. Now the Pendulum Lab is mandatory for the CSEC labs, so it means that also if you're a private candidate, so you're doing paper 3, it can pop up there as well. And they do bring the topic in papers 1 and 2, so you need to make sure you understand how to do this. Now, this is a 2-part video, where in this first part, we're going to actually be doing the lab, and in the next part, we're going to be going through the write-up. Now, the procedure that I'm going to be using is coming from this book. Now, in one of my shorts, you'll have seen that I mentioned this book has all of the lab stuff, so we're going to be using the procedure from there, but you'll see that in more detail in the next video. So let's talk about the objective first. Now, that is really our springboard from where we get the entire lab going. So the objective for this is to investigate the relationship between length and period of a pendulum. Now, in an ideal world, we would have done this in school already with our teacher, so we know what we're getting into, but we know with time constraints and stuff, that doesn't always happen. But as good students and budding physicists, we would do our due diligence and go and do a bit of research before the lab. So a couple of things that we should research essentially break up our objective into smaller things, like what is a pendulum, what is period, or what is the period, how does length affect period, and what are the other things that affect period. Now, if we do this, we realize that this is a pendulum bob, as in we have the bob and a string, and this together is the pendulum bob. You realize that period is just the time it takes for one oscillation. So essentially, you have this at one point. How long does it take to go to the other end and come back? So some people measure this different ways. Some start from here, and they'll count a period as when it swings to the other ends and then comes back here. Or if you want, you could start from one side. So you check the time it takes to go from here to the other side and come back. As long as it makes one complete oscillation, that is a period. You'd also realize that the only thing that affects period is the length. So from that, we could kind of make sense of the fact that we are going to vary the length and see how the period changes with that. So if we're varying the length, that means that length is the manipulating variable, and then the period is the responding variable. If you want as well, you could go on YouTube and look up some videos of how people are doing the lab. So it seems easier, you could check out some simulations. I will link both videos and simulations in the description box, so you all can check them out to be prepared before you do the lab. So let's actually jump into the lab now. So we have our pendulum bob attached here. I have this attached to my retort stand. I have, since we're going to be varying length, we could use a meter rule. I just have my meter rule back there, and I'm using this since it's exactly the length that I need, because I'm starting with 50 centimeters. And I have my stopwatch, because if we think about it, if period is the time it takes for one complete oscillation, we need something to measure the time, so we have our stopwatch. So what are we going to do? We are going to use it at one length, and we are going to count 20 oscillations and time that 20 oscillations at this length. And then we'll shorten it to anything. Some people might decrease it by 2 centimeters and then check the time for that. Some people might decrease it by 10. But the point is that we are using different lengths. So even if your teacher is using a different value to change it to, as long as we are changing the lengths and counting the time it takes for those oscillations, we're good to go. So I am starting with 50, and then I would reduce from there. So from 50, I could go to 48, 46, 44, 42, 40, or I can do 50, 45, 40, 35, 30. So basically, we're just doing pretty even intervals and see how the period changes. Now we're going to calculate the period afterwards, so we need to measure the time because the time for those 20 oscillations is able to give us the period. One of the things that we do is rather than just do it once at each length, we would do it twice at each length, because then we could find the average, because we know in case I did something wrong, it kind of knocks somehow, so the time changes from what it should have been. If I do it a second time and find the average, then I'm reducing the error, which is another precaution. If we think about it, we could list that in our precautions. So I measure my 50 centimeters. Now the 50 centimeters has to go from the top of the string to the center of the bulb. What am I saying bulb? And this is not 50 to the string, this is to more or less the center of the bulb. So what am I going to do? I am going to hold this up here, and I'm going to release it and let it swing 20 times. Now I am not going to apply any force because then I'm throwing off the readings. So I'm just releasing it, and I'm going to get my stopwatch and count 20 oscillations and time it. Now to release it, I'm going to do a countdown method, which is another thing we could have in our precautions, because it reduces the probability that we release at a different time from when we start timing. So I'm going to say 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got 30.56 seconds. So I am going to record that. Now I'm going to do it a second time so that I could find the average of both of them. So I make sure it's stabilized, and then I bring it up again. Remember, I'm not applying any force, and I'm doing the countdown method. So I'm going 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now I got 30.62, so I'm recording that as T2. 30.62, so that's not bad. 30.56 to 30.62. So I'm not going to do any of the calculations now, I'm leaving that for afterwards. But now I am going to record the next set of values. Now what does that mean? It means that now we are going to shorten our string, because remember we're changing the length. So we just did this at 50 centimeters, now let's do it at 45 centimeters. So I am going to shorten this a little bit. And I'm going to measure here. It's not short enough, so I'm going to shorten some more. Now, if it doesn't end up being perfect, then that's fine. Just measure whatever length you have, because it's still valid as long as you put the correct length that you have. So even if I end up with something like 42, I end up at 45. Yeah, 45. So I'm going to do the same process again, which means that now at this new length, and let me measure that, we'll record that new length. So Now, I am going to do the same thing. I'm going to do 20 oscillations again, count that 20, take down the time, and then do it a second time so that I can find the average of both. So, I'm coming up here, and I'm doing the countdown method. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now I got 28.69, so I'm going to take that down, and that is T1. So then I'm going to reset my stopwatch, wait for this to stabilize, and I'm going to do the same thing again to get T2 for the same length. Put it up, and really try my best to pull it up to the same place, but then notice that that is another source of error. Because what if one time I hold it here and then another time I hold it here? I kind of want to have it in the same range. So we had, what precautions do we have so far? That we used the countdown method, that we did 20 rather than just doing one period. Because if we just count for one, then we know that could throw off things a little bit. So that's why we're doing 20 as a precaution. Then we're doing it 2 times as another precaution. And we're doing the countdown method as a precaution. But one of the sources of errors could be parallax when we're measuring the length of this, because it's possible that I might have been off by a millimeter or 2. Then another source of error could be that maybe I did not put my hand in the same place. Or maybe you might do something to make sure that you always pull it to the same extent, so you could put that in your precaution. Because remember, precaution is something that you do to reduce the error, while a source of error is something that, an error that actually occurred. Meaning if you did something to eliminate an error, that is no longer an error because that did not throw off your readings. So let's continue. So I'm at pretty much the same place, and I am going to do 20 counts. 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now I got 28.53. So we got our readings for 50 and 40 and 45. What am I saying? 40. So now we are going down to 40. So let me shorten this a bit. And when we measure, still too long. Now I've done it a little bit too short. Now if you want, you could keep that length that it's at there and just measure. Like if it was 38, you keep that, but I'm a little bit fussy, so I'm going to try for the 40. Now it's a little too long. Right, so we have 40, so I'm going to record that. So we're going to do the same thing again. 20 times, and we'll do that twice. So I want to get 5 sets of readings. So we already have 50, we already have 45. Now we're going to do 40. So I'll do 35 and then 30, and we will use that to do all our calculations. So I'm pulling it back here. 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Because I'm counting for here, like I swear I'm making a mistake and forgetting how to count for this. So now I have 26.94. So I'm going to reset and I'm going to stabilize and do the same thing again. So 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now I got 27. That's actually really close. Now I'm going down to 35. So this time I'm going to try holding this up at like 35 and see if I had like someone else with me, so I could do a lab partner. I could hold this here and they could have pulled this until it reached here, but I'm all alone. That would be very weird and cringy. So I am at 36, so I'll do a again. I'm still at 36. I don't know what I did there. And now I am at 35. So I already recorded my 35, and by now we know the drill. We know we're going to do 20 oscillations, time that, and then do it again and time it. So I'm coming here again. 3, 2, 1. 1. I feel like my hand kind of shook it a little bit. So because I noticed that, I am going to do it over, because I don't want that my hand throws it off. So when it's swinging, you notice sometimes there's a slant, and okay, we could live with that, but I don't want that I accidentally tap it and throw it off. We're trying to reduce errors here, and we don't want our graph to come out weird. So 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got 24.94. For the last one I got 26.94. So stabilize and we go again. 3, 2, 1. Okay, let me do it again. 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this one is off by quite a bit, so if you want, you can do yours over. I got 24.94 for the first one, and then I got 25.19. So maybe something went off with how I released it or something, but we will press on. So now I am going to 30 centimeters. So let me try and shorten this a bit. Shorten. And the hardest part in all of this, honestly, is to remember not to slouch. So I am here, and I'm trying 30. Now I think I shortened it a little too much. Oops. So this is not my favorite type of clamp, but it's what I have. So we'll make it do. I prefer the other one that could hold the string a little bit better. I might have to invest in one of those if I continue with these videos, but we will see. So I think that is good enough for 30. One thing that you can do to help yours to make sure you get to the center of the bob is maybe to make a mark here so that you always know where you're stopping. So I already recorded 30, and then we know the drill. 20 oscillations 2 times. So 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got 23.78. One thing that you can keep in mind too is that reaction time will be one of your errors, because it's possible that when it reaches up here, I take too long to press the timer, so it already starts going back down when I press it, so my timing will be off. So we have another source of error there. So I'm going again for my final time. 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got 23.69. So everybody looks pretty good, to be honest, except for that second reading for 35. So for the sake of laziness, as well as maybe checking to see if that value will be very skewed, we'll keep it as it is. So then in the next video, when we're actually calculating the average time and calculating the period, we'll see how off that actually is, if it is actually off. So that's it for how we do the lab. Now, if you're doing this in school, you know you'll be a good physicist, a budding physicist, and we will pack back our lab equipment as we're supposed to. We won't leave them lying around. But I hope this helped a little bit with how you do the lab. And remember, look out for the next video where we actually go through the entire item. So I can't remember what I usually say at the end. It's been so long since I've made a video. But be safe, be kind to yourself, guys. See you all next time. Bye bye.